This is the next in a series talking about factoring. We've factored a lot of polynomials using greatest common factor. We've factored uh, using a variety of methods, and so today we're going to take that factoring that we've learned and we're going to apply it to quadratic equations. Now, the difference between just factoring a normal polynomial and factoring an equation is that now we're going to take the factoring methods that we've used and we're going to solve for x. So basically what happens is that a quadratic equation actually has an equal sign in it. And the standard form of a quadratic equation has an x squared term, an x term, and then this represents just a constant, a number. So a and b and c are just numbers, and then the variables are x's. They could be y's or t's or r's or any letter basically, but basically the variables are, there's one that's squared and then one that's not, and then everything else is a number. Okay, so what happens is whenever you are factoring out this quadratic equation, you're going to get something like you did before where you have, a number or variable combination multiplied by itself, typically two binomials, something in this format. So how does that help you solve the equation? Here's how. When you have factored form, so you have something times something instead of the whole quadratic all combined together, then you set them equal to 0 because you're going to rearrange the equation so that everything's on the left and the only thing on the right is a 0. And so when you have two things multiplied together that equals 0, you can use something called the zero product principle. Now, the zero product principle means that if this is 0, if this is equal to 0, and you multiply 0 times any number, you'll get 0. So, for example, if this part is 0 and you multiply it by 6, you'll get 0. So if this guy is equal to 0, then the whole thing will be equal to 0. What about this other part? Well, let's say that we set this, or that this is equal to 0 and this is equal to 7. Okay, so 7 times 0 is equal to 0. So whether the first term is 0 or the second term is 0, it makes the whole thing true. It makes this whole equation true. So we can find values of x, or whatever your variable is, to solve the equation by using this principle. So basically, in short, it means that if you have two things multiplied together and they're equal to 0, whether the first one's 0 or the second one is 0, it doesn't matter. It will make the equation true because 0 times anything will be 0. 0 times anything will be 0. So let's see, how does this apply, right? Because it seems like a bunch of wishy-washy talk about zeros. So let's apply this to the quadratic equation. So we have this quadratic equation. We know it's an equation because it has an equal sign. It's not just a quadratic expression. All right. So we're going to do more than just factor. We're actually going to solve. So we're going to factor the way we did before. We know x times x is x squared. We know something times something is going to give us 10. And whatever we do to multiply to get 10 also has to add up. The middle terms have to add up to the middle term here. So the inside plus the outside has to equal negative 7x. So after doing a little searching, we decide that negative 5 times negative 2 will give us positive 10. But then when you add them together, you'll get the middle term. All right, so we've factored it. So what? Well, what are we going to do with it now? So now that we have it factored, we're going to use that zero product principle that says, hey, this whole thing is equal to 0. So if this side is equal to 0, it makes it true. If this side is equal to 0, then it also makes it true. So we set this equal to 0, and we set this equal to 0, and we solve for x in both terms. Again, what is our goal here? Solving for x. And you can't solve for x if it's got a square term and a regular term. So you have to use other methods such as the quadratic formula or factoring. All right, so according to this, x can be 5 or it can be 2. So we try it. If x is really 5, does it make this equation true? So we plug 5 in everywhere there's an x. So instead of x, we put 5 squared. Instead of x here, we put a 5, and we just see, does this work? Are we going to, we're going to check it to see if 5 is a solution to this equation. Yes, it is. When we plug it in, it actually makes the equation true. What about 2? We do the same thing here. We put 2 in everywhere there's an x, and we substitute it in, and then we say, does that really equal to 0? So when you evaluate it, you notice that this is a solution. So you've solved for x. Now, since x has more than one solution, you write it in the form of brackets, because these are the solutions to the equation, and you put the lowest number first, like if you were on a number line, so the negative numbers would go before positives, and you put the lowest and the highest, and you just separate it with a comma. This is called your solution set, so because there's more than one answer. All right, so let's do some more. Okay, so here's another example. Well, what's different about this example is that they've already factored it for you. So it's not a whole quadratic equation that you have to factor, it's already factored. So going back to the zero product principle, if this is equal to 0 and you multiply 0 times that, the equation will be true. If this is 0, if the value of this is 0 and you multiply it by something else, it doesn't matter what this other stuff is, this equation will be true. You'll get 0. So we take the first part and set it equal to 0. We take the second part and set it equal to 0, and then solve for x. So x could be 1/3 or x could be -2. So if you put 1/3 and -2, either one, into this equation, when you check it, you'll notice that those are solutions. They're true. They check out. So then you write your final answer in brackets, the lowest number first, a comma, and then the next number. Now what happens if, for example, you plug it back in and it doesn't work? Well, if you do that, then that is not a solution. You would have to throw it away. That's called an extraneous solution. Or what happens if you put all of your answers back into the original equation and it wasn't true? You got something that said like 5 is equal to 0. Well, 5 is not equal to 0, but if you put it in there like that, then that would mean that there's no solution. If there's no solution, in other words, neither of your answers actually check out, then you would put this symbol. It stands in the brackets and it stands for the empty set. That means that there's no possible real solution to this equation. There will be imaginary solutions, and we'll get into that later, but basically there's no real numbers that would fit into that category. So that's just a scenario if the ones that the answers that you solve for when you go back to check them in, if they don't work in the original equation, then they're not a real solution. It's called extraneous. Okay, so it says solve the equation. So what we do here is we take this first one, set it equal to 0. We take the second one, set it equal to 0. Why? Because 0 times anything will equal 0. And so you solve for x. Remember to write your solution in brackets. All right, so what if it's not factored, like that very first one? So you're going to follow these steps. You rearrange the equation so that there's only 0 on one side and everything else is on the left. You factor out any greatest common factor that you might have. In other words, is there something in common that you can take out first to simplify it, like a 3x or whatever? You also factor using difference of squares, or maybe other methods that you've learned, factor by grouping or whatever. Then each of the factors, no matter what it is, whether you have a binomial times a binomial, or maybe you have something out here, so anything that's multiplied that you've factored out, like in this case, this is the greatest common factor, and then these are the binomials, like typical. So if you pulled out a greatest common factor and then you simplified it even more, everything that's multiplied would be set equal to 0. So this would be set equal to 0, this would be equal to 0, this would be equal to 0, because if any of those are 0, it makes the equation true. You solve each of those little equations that you set equal to 0. You might need to go back and check your answers. And then you write your answer in solution set form with these brackets. Remember, if there's no solution, you can say that it's prime, or use that special symbol, or say that it's an empty set. So let's do a few. All right, so solving by factoring. So here's an example. Well, the first thing we know is that the first term is not just x squared. It's 2x squared. So we know that 2 can only be factored into 2 and 1. So we may have to try a couple different options, because the second part is a -4. So -4 can be -1 and 4, 1 and -4, or 2 and -2. And again, since this is not a 1 here, if these were both 1s, you could just try them, 3 sets. But since there's a 2 here, the -1 has to be tried over here, and a +4, and the -1 would have to be tried on the other side, because those are two different answers since the 2 is here. So in other words, the outside gives you 8 minus 1 is the inside, so that would give you 7 as the middle term. The outside is -2 and the inside is 4, so that would give us 2 as the middle term. We're looking for a 7 to be the middle term. So you may have to try a few options. And again, you might see this and say, you might notice right away that you need it in this combination. So the outside is 4 and the inside is -2. Oh, wait, let's go back. Okay, so this one was right. Sorry, the very first one was right. My apologies. Okay, so anyway, you might have to try different options. In this case, we found it on the first try. I just didn't recognize it. Okay, so then this is our answer. So now we have to solve it. Before we just factored, and so we could just stop. But in this case, we want to actually solve it, which means if this is 0, 0 times this will be 0. So that would make it true. So we set this equal to 0, and we set the other one equal to 0. So we get 2x is equal to 1, and x is equal to 1/2. So here we solve x is equal to -4. So those are my two options. All right. And let's look and see how we did it before. That's exactly what we get. And then we write it in the brackets with the lowest number first and then the second number. All right. Now you may be asked to check your answers. And in the future, you might want to check for extraneous solutions. But when I look at this, I can go back and obviously see that these will both work. All right. So try this in earnest. Stop the video and try it, and then come back and check your answer. Okay, hopefully you got this. Okay, there's a couple more examples here. Again, when you think you know how to do something, do a couple, and then when you're confident that you know what you're doing and you're getting them right, do 3 more. Okay, because there's always a little bit of a tweak with future problems, especially at the end of the unit or the end of the set. So if you feel really good about doing the problems, go all the way to the end and try to do the last few problems, because usually there's some kind of twist on those. All right, so try these. What's weird about this? Well, first of all, it's not equal to 0. So we have to subtract 2x from both sides so that you get 0. Now there's no c here. This is an a, x squared, and bx and c. So there's no c here. But what do I notice? There's a common factor. If I take an x out, this is what I get. Okay? Now I don't have to do any more factoring because this is the lowest form. So our zero product principle says that if something times something is equal to 0, then if either thing is equal to 0, it makes the equation true. So that means x could be 0 or 2/3. And then you would write it in that form. Okay, what's special about this? Well, again, these things are on the wrong side of the equation. So I'm going to subtract 6x from both sides, and I'm going to add 9 to both sides so that I have 0 on the right-hand side. Now you need to factor it and solve each factor. This is what you'll get. All right, we're doing a couple more. This one is when you subtract 16 so that there's 0. This is called a difference of squares. And you're going to want to factor it with a plus b and a minus b, and then solve each factor. And then this last one, you need to FOIL it first. And then move the 6 to the left and then refactor, because I needed that 0 there. Then you're going to refactor it and then solve.